Alright mates, let's talk about something that sounds like it's straight out of a wild science fiction movie, but it's actually real. Imagine going on the most epic journey you can think of. A trip across the stars to distant galaxies and unknown worlds. You're gone for what feels like just a few years, maybe seeing sights that no human has ever laid eyes on before. But when you finally come back to Earth, you find that everyone you knew, your friends, your family, they've all grown old. Decades, maybe even centuries have passed. You, however, haven't aged a day. It's a mind-bending idea, isn't it? This isn't just a cool story, it's a real possibility based on some of the most fascinating science in the universe. This incredible phenomenon is called time dilation, and it's one of the most curious and brilliant ideas ever cooked up by a bloke named Albert Einstein. He figured out that time isn't the steady, constant thing we all think it is. Instead, time is flexible. It can be stretched and squeezed, kind of like a piece of cosmic chewing gum. In the entire universe, there is one ultimate champion of speed, and that's light. Light travels at an absolutely mind-boggling pace, about 186,000 miles per second. That's fast enough to circle the Earth more than 7 times in the blink of an eye. Einstein realized that this speed is the absolute maximum speed anything can travel. Einstein figured out that space and time are woven together into a single fabric he called space-time. Think of it like a giant, stretchy trampoline. When you travel incredibly fast, you are essentially stretching out that fabric of space-time. And this warping is what causes time dilation. To really get our heads around this, let's imagine a story. Let's create a brave explorer named Elara. She's about to pilot a brand new type of spaceship, one that can travel at 99.9% of the speed of light. Her mission is to journey to a newly discovered planet orbiting Proxima Centauri, which is about 4 light-years away. On the day she leaves, she says goodbye to her twin brother Liam, who stays behind on Earth. They are both 30 years old, full of dreams and excitement for the future. Elara climbs into her sleek silver ship, the Star Drifter. The engines roar to life, and with a powerful push, she accelerates into the vast, dark emptiness of space. From her perspective inside the Star Drifter, everything seems perfectly normal. The clock on her wall ticks every second, just as it always has. But back on Earth, things are very different. For Liam, time is marching on at its usual pace while Elara is racing through space, barely moving through time. Let's break down the numbers to see just how mind-bending this really is. For every single day that passes for her aboard the Star Drifter, nearly 22 days pass back on Earth. So, when she experiences 1 week in the quiet solitude of her ship, her brother Liam experiences almost 5 months. An entire season on Earth would fly by in what feels like just a few weeks to Elara. Imagine Elara sending a video message home after her first month in space. By the time that message reaches Earth, Liam would have already lived through more than 2 years of his life. Their conversation would be stretched across decades, a slow and disconnected dialogue between 2 different streams of time. The entire world she left behind would be moving in fast forward. Friends would get married, children would be born and grow up, and entire cultural movements could rise and fall, while her ship remains a small, slow-moving bubble of time. This isn't just a fun thought experiment. It's a direct consequence of Einstein's theory of special relativity. After what felt like a 2-year round trip for Elara, she finally pilots the Star Drifter back into Earth's orbit. She is 32 years old, full of energy and incredible stories of alien landscapes. As her ship descends through the clouds, she sees the world below. The cities look different, more sprawling and advanced than she remembers. While she aged only 2 years on Earth, roughly 80 years have passed. The year is no longer 2055, it's 2135. She would find his grave, a weathered stone marking the life of a man she knew as her twin, her other half. The life she was supposed to live alongside her brother has vanished into the past. Elara's return would be a lonely one. She would be a marvel of science, but she would also be profoundly alone, disconnected from her own time. Her story would be a cautionary tale, a powerful reminder that to travel the cosmos is to sacrifice your place in the normal flow of human history. The principles of time dilation are already a part of our modern world. One of the best examples is the Global Positioning System, or GPS. The GPS satellites are moving very fast, about 14,000 kilometers per hour. This high speed means that the clocks on board those satellites actually tick slower than clocks on the ground. Back in 1971, physicists Joseph Haefel and Richard Keating took incredibly precise atomic clocks and put them on commercial airplanes, flying them around the world. When the planes landed and they compared the clocks, the results were exactly what Einstein's theories had predicted. It was direct proof that you could travel into the future, even by a tiny fraction of a second, just by getting on a plane. Even astronauts living on the International Space Station experience time dilation. The ISS orbits at about 17,000 miles per hour, much faster than a commercial jet. Because of this incredible speed, astronauts on the ISS age just a little bit slower than we do down here on Earth. It's another beautiful example of cosmic physics playing out right above our heads. Thinking about time dilation has huge implications for the future of human space exploration. As we dream of sending astronauts on longer missions, perhaps to Mars or even the stars, we have to grapple with relativistic time. Imagine a generation ship, a massive vessel designed to travel to a distant star system over many decades. Because of their constant high-speed travel, time for them would pass slower than on Earth. This raises profound ethical questions. Is it fair to send a crew knowing they will be permanently disconnected from their home timeline? These explorers would need to find their sense of home entirely within their ship. They would be pioneers, but also orphans of time, knowing that the world they left behind is racing into a future they will never see. On the other hand, time dilation could be seen as a tool. It offers a kind of one-way ticket to the future, a way to cheat the vast distances of the cosmos. For humanity to truly become a multiplanetary and interstellar species, we must understand and embrace this strange, beautiful, and challenging aspect of the universe. So, we come back to where we started. The mind-bending truth that time is not a fixed, universal clock. It's personal. Your time is different from my time, which is different from the time of an astronaut speeding through space. This idea, born in the brilliant mind of Albert Einstein over a century ago, continues to shape our understanding of the universe and our place in it. This mystery is part of what makes space exploration so incredibly exciting. We are not just exploring new places. We are exploring new ways of experiencing reality itself. The challenges are immense, but the rewards are equally vast. The chance to see new worlds, to answer ancient questions, and to understand the cosmos on a deeper level. Will humans one day board starships and return to a world transformed by centuries of progress? These are no longer just questions for science fiction writers. They are real possibilities that future generations may have to confront. The universe has laid out the rules, and it's up to us to see how far we can go within them. Time might be flexible, but our drive to understand it is constant. And in that quest for knowledge, we find the true adventure of being part of this incredible mind-bending cosmos. The journey is just beginning.